good afternoon class. In my yesterday's lecture, we discussed internet addressing or logical addressing, which was used by the network layer to uniquely identify a device in different networks. Today, we'll be doing IP protocol or internet protocol, which is the most importantly used protocol in the network layer. Then we discussed TCP/IP protocol suite in unit 1. I hope you remember this was our network layer, and this network layer we discussed very briefly these protocols: IGNP, ICNP, IP protocol, address resolution protocol, reverse address resolution protocol. I have even dictated you 119 definition of these. Today in this lecture we'll in detail discuss this IP protocol. Basically, this is the transmission mechanism used by TCP/IP protocol, and it is unreliable and connectionless protocol. What I here mean by unreliable is that it do not provide us error correction or detection mechanism, and also it is connectionless. That means there is not a prior connection made first and then the datagrams are sent. The datagram followed different path. A huge message is divided into small datagrams. Those datagrams follow different path and they get reassembled at the receiver end. So this is a connectionless protocol. In another word, you can say that this is a best effort delivery mechanism that this network layer do its best to deliver the correct and the right message to the receiver, right? Today we'll be in detail discussing what is the IP header structure. As I have told you earlier, each and every layer adds a header along with the message. Today we'll be discussing what all things are there in an IP header. This is an IP header. Total, it consists of 20 bytes to 65,536 bytes. This is header plus data together is known as a datagram. A header is from 20 to 60 bytes. The size varies depending on these information. Minimum size is 20 bytes. Maximum size can be 60 bytes of a header which is being added by the network layer along with the data. In detail, we'll discuss what all fields are there in a header. In my notes, I have also shared my handwritten notes with you. The detail of each and every field is written there. I'll today also share the scanned copy of Data Frozen book of 4th edition. This topic plus IP addressing topic is not there in your 2nd edition, which I have provided you earlier, the scanned copy. Along with this video lecture, I'll give you the scanned copy of the book so that if you want to do detailed study, you can refer to the book, right? I'm providing you both my handwritten notes and the book as well. Please read the notes first so that you can understand easily, but do refer to the book for the detailed version. Now let's start with the first field. First field is version field. It is 4-bit long. 4-bit of long. Version tells us which version of IP addressing is it, version 4 or version 6. Right now we are discussing IPv4 datagram. So the version stored here will be 4. Next is the second field is header length. Header length tells what is the total length of this header. It from 20 to 60 bytes. It defines the length of the header in multiples of 4 bytes. Means the length is 4 bits. 4 bits matlab when we write it in the decimals 00002 4 times 1. That means you can uniquely identify 0 to 15 decimal values. So when you write 0, you multiply it by 4. That means 0 is the length. If you maximum is 15, 15 multiplied by 4 is 60. That means 60 bytes of header. So the header length is defined in the multiples of 4. The third field is service type. Service type defines how the datagram should be handled. It defines basically the priority of the datagram. It also specifies the type of the service the sender desires. For example, level of throughput, like you want high level or low level, or you want throughput is not your priority. reliability is your priority, or you don't want the delay, or the delay can be there. So basically you are defining this type of services which are expected from this datagram. The next field is total length, which is 16 bits long. This total length tells the total length of this datagram. Earlier header length was defining only the length of the header, but with this total length defines the total length of the IP datagram. Next field is identification field, which is 16-bit long. Basically this complete header we have divided into 32 bits, right? So this 16-bit is identification field, which is used in fragmentation. As I have told you earlier, the big message is fragmented into small datagram. When datagram pass through different networks, they may be divided into fragments to match the network frame size. Each fragment is identified with the sequence number in this field, that this is packet number 1, 2, 3. So these sequence numbers are stored in this identification field. Next is our flag field. Flag field is 3-bit long. 1, 2, 3. We are dividing into 3-bit. First bit is reserved. We do not use it here. Next bit is D. D for do not fragment. If this bit is 1, that means the machine comes to know that this datagram is not allowed to be fragmented into small fragments. The last third bit is more fragment, which tells you that I have received a datagram, but it has further following fragments which are coming on the way, right? It tells you the datagram is not the last fragment if it is 1. If it is 0, that means it is the last fragment. Next field tells us fragmentation offset, which is 13-bit field. It shows the relative position of this fragment with respect to the whole fragment, right? What do we mean by relative position? Like suppose we have a very big fragment datagram, we have divided into fragments. Maybe I'm dividing into 1,000 each byte. So it tells me the relative position, that second fragment, third fragment, or third into 1,000. That means 3,000th bit it is. Right, so basically you are telling fragmentation offset tells you the relative position of that fragment with respect to whole datagram. We'll discuss the next field, which is time to live. Time to live defines you number of hops a datagram can travel before it is discarded. I have told you earlier, when a packet moves from one network to another, first it moves to a router which connects your network to the outside world, then it moves to different router which comes in between, then finally reaches the router of the destination. So each and every datagram has a time to live, that how many hops it can take maximum before it is discarded. Why it is to be discarded? Because many times the datagram lost their path, that they do not reach the destination, but they keeps on hopping the routers. So unnecessary, we are not wasting the network capacity. So maybe let's say it's 100 hops. So if it is moving here and around in a vicious circle of the routers, after 100th jump it will be automatically discarded and the network space will be freed. Next field we'll discuss is protocol field. This is a 8-bit field. It defines which upper layer protocol data are encapsulated in the datagram. Upper layer, network layer के ऊपर is transport layer. Which upper layer protocol is used? TCP, UDP, ICMP, etc. These are the protocols which are being used by the transport layer. Next is header checksum. It is a 16-bit long field. It is used to check the integrity of the header. I am talking only about the header. We are not checking the integrity or any error in the data. We are only checking the integrity of the header, that the header is received in correct form. Next, it's a source IP address. This is a complete 32-bit long field. Source address identifies the original source of the datagram, from where the data has started. The original IP address, which is a unique 32-bit address, is stored in this field. In the next field, destination field, you store the final receiver's address, final destination, which is a 32-bit IP address of the destination, which is stored in this field. The last field of this header is option. Optional gives you actually, instead of these functionalities which are already being defined, you define more functionalities to your IP datagram. It can be carry fields that control routing, timings, etc. Some additional functionalities are added to this IP datagram. So here we have discussed IP protocol datagram. I'm also giving you the PDF of the book. Please follow this, and if any doubt or any um, thing is not clear, do comment me in this video. I'll get back to you. Thank you.